Thank you, Hillary. Welcome to Ashby Village Science and Ideas Group. My name is Joe Evinger, and I help coordinate this group's events with the help of our co-host and tech expert, Hillary Naylor. All of our members here have varied education and work experience backgrounds. We all share one thing in common. That's science and new ideas. We currently have over 70 members. We meet on the second Thursday of every month from 3 o'clock until about 4:30. We have a different guest speaker every month who speaks to us on a topic related to science and ideas. We rely on our group members, all Ashby Village members, our invitees, presenters, and others for ideas about new speakers and ways to connect with them. Here are some future speakers that we have. On June 13th, Dr. Jonathan Flint, a psychiatrist and geneticist, will present a talk entitled The Genetics of Behavior. Dr. Flint has done extensive studies into the causes of depression. On July 11th, we're going to do something a little different for us. Mary Mackey, who has a PhD in comparative literature, will present to us a talk entitled Creativity and Thinking Out of the Box. In September, Seacology, whose mission is to protect threatened island ecosystems from all over the world, will present to us. Recently, just a day or two ago, I sent an invitation to someone who has just written a book about poisons, good poisons and bad poisons, and hoping to get him to speak to us later on this summer or fall. We're always looking for new speakers. We have openings in August, October, and November, and they're out. If any of you personally know someone, please recommend them to me and send me their contact information. We invite all Ashby Village members to join our group. Others interested in Ashby Village and our presentations are also welcome. Got to do a commercial. Ashby Village is a 501c3 tax exempt organization, currently having a funding drive now. I'm asking Hillary to please place a link in the chat if you decide to donate to us. Please consider, particularly to our guest today, please consider a donation to Ashby Village so we can continue presentations like we're about to see today. We'd like to thank Hillary Naylor for introducing us to today's speaker, and to Sarah Evinger for helping preparing today's presentation. And she will present Robert Todd. Sarah.
Hi, everybody. Great to see you all here. I'd like to introduce Robert Todd, who is an innovator, educator, and tech executive. He has made significant contributions to the fields of education, technology, and organizational transformation. As a pioneer of e-learning in the late 90s, Robert helped revolutionize the way people learn and acquire knowledge. His passion for leveraging technology to enhance learning and change behavior led him to leadership roles at organizations such as Digital Think, McKinsey & Company, and LinkedIn. Today, as an advisor, educator, and consultant, he focuses on applying lessons learned from 3 decades, amplifying human intelligence to help individuals and organizations prepare for the emergence of machine intelligence. By the way, he's scheduled a class at Osher, at Ollie, as some of you know it, a hands-on with AI class, 4 weeks in June. Sign up before it gets full. Off to you.
Okay, Robert, and don't forget to unmute yourself.
Thanks. Thank you. I think I just muted myself instead of unmuting. Really happy, honored to be here, frankly, and look forward to the conversation. I'm hoping to move through this in about 30 to 35 minutes, so we actually have more time to talk, because I feel like there's a lot of stories and news and whatnot hitting people every day, and I have no idea what questions are at the forefront of your mind. So I'm going to try and lay a foundation, and then hopefully we'll have time for a little bit of a conversation. Can you see my robot, everyone?
I think you're showing us your talk right now, Robert. I think you.
Oh, that's good. Let's start that. Thank you. Yeah. Thank you very much. We'll try that again. My bio didn't say I was good with technology, did it? Let's just try that again. How's that?
Much better.
There we go. This is a talk about artificial intelligence, or AI. In the past few years, AI has gone from a topic mostly discussed by technologists and science fiction writers to something everyone is talking about. Over the past 18 months, tens of millions of people have interacted with an AI chatbot like ChatGPT, powered by one of the large language models like OpenAI's GPT-4, Google's Gemini, or Anthropic's Claude. Much of what you hear or read about the current and near future capabilities of AI probably sounds like hyperbole. Much of what I write, teach, and advise others about AI sounds like hyperbole to me. My hope for the hour we have together is that you will walk away with a bit more context than you logged in with, and are better able to engage in the societal conversation about what is almost certainly the biggest thing to ever happen to humanity, at least until the next biggest thing to ever happen to humanity comes along. But for now, this is it. The first thing we should do in this conversation is draw a distinction between artificial intelligence and the whole world of computer software that we've been living with for the last 30 years. Traditional computer software is what the technology world has been built on, from the introduction of the personal computer to the ubiquity of smartphones and the internet. While all the tools and technologies and infrastructure of the personal computer and internet eras are the foundations for building artificial intelligence, the way that traditional software works and the way artificial intelligence works are very different. To grossly oversimplify, traditional software works like a calculator, and artificial intelligence works more like your brain. A traditional software program like Microsoft Word or any of the apps on your phone is a set of explicit step-by-step instructions in the form of something like, here's a list of numbers. Read the first number in the list. If it is greater than 0, then multiply it by 5 and write the result in this other list over here. If the number is equal to or less than 0, skip it and read the next number in the list. Repeat. Now, with skill, you can combine enough of these explicit step-by-step procedures, and you can make a computer do just about anything with numbers. And because we've learned over the past 30 years how to turn information in any of its forms into numbers, a process called digitization, computers can manipulate text, sound, images, video, 3D models, etc., in almost any way that we can imagine. I can use software to send a text message to a friend's phone, color correct a photograph, or create dazzling special effects for movies. Traditional computer software gave us an unprecedented ability to create, manipulate, store, and retrieve information. Now, traditional software is also a huge pain in the butt to build and maintain, which is why there are so many highly paid software engineers. Everything a traditional software program can do is something that a software engineer wrote explicit, detailed instructions for. What's great about that is that software program will give us predictable, reliable results. If I press the button in my word processor that is supposed to make the text bold, it will make the text bold every time, no surprises. And over the years, as programming knowledge and tools have gotten better, software has gotten more and more reliable and actually relatively boring, if by boring you mean no surprises. It also means that every time I want to update the software to do something even a tiny bit different than what I told it to do before, something that happens constantly in the world of software, I have to write new explicit instructions for it. And sometimes when I change instructions in one place, it breaks instructions in another place. So making changes can be complicated. It also means that if software does not get exactly the kind of input it expects, like if I format a phone number wrong when I'm filling out a form online, the software refuses to accept my input. It just doesn't work. You and I do not work like that because we are intelligent. If I give you instructions about how to count apples, and I show you, here's one apple, and I put it together with this other apple, that's 2 apples. And you're like, cool. And then I say, what if I put one orange with another orange? How many oranges do I have? You say 2 oranges. And that's because you can generalize. And generalizing is a major feature of intelligence. Now, if I write a software program with instructions that say 1 apple plus 1 apple equals 2 apples, and then I ask it about oranges, it will say some version of what's an orange, which is a sign that traditional software programs are not intelligent. They lack even the most rudimentary intelligence. Now, computer scientists have been interested in the idea of building intelligent software, intelligent machines, from the beginnings of computer science. In the 50s, a bunch of them got together for a summer conference at Dartmouth University and said, hey, let's try and figure out how to make computers that can think, computers that are intelligent. They called their little confab the Dartmouth Summer Research Project on Artificial Intelligence, and that's where the term AI came from. They broke up the intelligence problem into a bunch of parts, like how to build computer vision and computer reasoning and planning and language understanding and navigating in the physical world, things we associate with human intelligence. They spent the whole summer having workshops and discussions. They didn't really solve anything, but it was a start. And most of the attendees went off in their own directions to work on solving different parts of the artificial intelligence problem. Most of these researchers tried to solve the intelligence problem using approaches that were similar to the explicit instructions in traditional software. After all, those approaches and the field of computer science had only been around for a couple of decades at that point. These methods, these old school methods, are known as symbolic AI, or literally good old-fashioned AI. Symbolic AI tried to teach computers to reason by giving them rules about formal logic or rules about grammar and syntax, basically taking the formal rules and knowledge that humans had accumulated about how the world works and teach those rules to computers, kind of like we try and do with kids, which doesn't really work, but that's another story. By analogy, instead of writing instructions about how to add apples and then a different set of instructions about how to add oranges, I teach a machine how to add fruit. And then I make a list of all the different kinds of fruit. And now I have a program that can generalize, sort of. That is, of course, until I ask it to add one durian to another durian, and it says, what's a durian? For a few decades, artificial intelligence, this very visionary and challenging branch of computer science, had periodic successes in creating smarter software. But those successes would consistently hit a wall where progress stopped. Researchers called this period of ups and downs AI summers and AI winters. In hindsight, it's easy to see why things kept breaking down for them. One, oops, that was my symbolic AI slide. I forgot to show you that one. Symbolic AI. One of the big problems that they faced that we can see in hindsight is called the knowledge problem. The programs that they built, the AI programs they built, lacked information about the world, which kept them from being effective at problem solving outside of very narrow constraints. Often they would get them to be able to do things in a simulated environment where all the conditions were managed. One fairly famous research project called the Psych project, CYC, Psych, tried to fix this by teaching the computer everything about the world as a set of explicit statements of fact, like water is wet, cold water is ice. People can drown in water, but not in ice. People need water to live. If you put people in ice water, they die. People wear wetsuits to keep warm in cold water. If I now ask Psych if I can wash a suit in water, it's not going to tell me to take it to the dry cleaners. It doesn't have enough information about the world, and it's never going to get there with explicit instructions. Number two, their computers were just very small. In 1984, when the Psych project started, so this is 25 years after the Dartmouth conference, the Cray 2 was the most powerful supercomputer you could buy for about $50 million 2023 dollars. The graphics card in your laptop is about 10 times more powerful than a $50 million Cray 2. So they had underpowered machines and they couldn't give computers enough knowledge. But a few of the researchers who attended the Dartmouth conference started working on a different approach than symbolic AI, based not on teaching computers formal logic, but on building machines that could learn for themselves from sensory data. Marvin Minsky actually laid some important mathematical foundations for machine learning in a paper on something called the perceptron, a kind of machine-based neuron. But then in 1969, he published a book on perceptrons with Seymour Papert that many claim shut down interest in machine learning and neural networks by exposing its limitations. It's probably unfair to blame Minsky and Papert, but nevertheless, there was very little progress on machine learning approaches to AI for a couple of decades following the publication of their book. So for several decades, while traditional software was delivering great benefits, first in large business and ultimately with the advent of the personal computer and the internet to the world at large, AI remained a research topic. Then in the 90s, due in some part to the steady growth of computer processing power, we saw the first narrow but useful applications of machine learning in things like fraud detection, speech and handwriting recognition, and recommendation systems. If we want to understand modern AI, we have to understand what machine learning is and how, in principle, it works. The most important thing to know about machine learning is that machines learn by analyzing data. So the smarter you want your machine to be, the more data you need for it to analyze. We could not have gotten where we are today with AI if it weren't for the internet and the exponential growth in data that it caused. There are a number of different approaches to machine learning that were developed to deal with different kinds of data and kind of intelligence. If you have labeled data, like a bunch of images where humans have labeled what's in the image, and the kind of intelligence you want is classification, i.e. you want the machine to be able to look at an image and tell you what's in it, you use something called supervised learning. If you want to teach a machine to drive a car or play a video game, and the data you have is a stream of sensory input, you use something called reinforcement learning. There's also unsupervised learning, semi-supervised learning, reinforcement learning with human feedback. It's a long and growing list, but every single machine learning approach does the following. It analyzes data about the world to learn a model of the world and use the model to predict the world. So that's, in a nutshell, what machine learning is. Analyzing data about the world to learn a model of the world that you can use to predict the world. When machines learn, the outcome of their learning is a model of the world or some aspect of the world. For example, a globe is a model of our actual world. You can't find the distance from Paris to Dakar with a globe. It lacks facts, but you can learn something about the relative distance from one place to another, and you can see which countries have access to the sea and which do not. I'm sure that people making globes consume a lot of detailed data about sizes and distances and positions of things on our planet's surface, but that data is not stored in the globe. The globe is a model that is an approximation of all that data. Machine learning models are just like that. And when we say machine learning models, we're saying modern AI. Modern AI, machine learning models are just like that. They consume a lot of data about something to create an approximation of that thing. And the relationship between the parts of the thing that can be used to answer questions or make predictions about what is or what could be in the world. So a good model will allow you to see things you can't see by direct observation of the data. If I look at our planet from my one vantage points, it looks flat. But if a model consumes all the positional data about the surface of the planet, it will end up with a model of a world that is round. This is how machine learning algorithms work. They create a model of the world that can be deduced by the data they consume, and then we use that model to make predictions about the world. The kind of model you get and what you can use it to predict depends on the data you have. So if we feed a learning algorithm data about people's activity on Facebook, it will learn a model that predicts that if people see inflammatory political posts, they will increase their activity on Facebook. If the machine learning model is in charge of your Facebook feed, you will see more inflammatory political posts. That happened. Machine learning algorithms drive social media and social media feeds and what you see. If you feed a learning algorithm data about what kind of credit card transactions happen just before someone reports fraud, it will learn a model that can predict fraud from transaction data before the credit card holder notices their card has gone missing, and sometimes when it hasn't gone missing. If we feed a learning algorithm every book, article, paper, website, tweet, and blog post on the internet, as we have done with the large language models like ChatGPT, it might be able to predict the answers to the bar exam. It can, or what a sonnet about periodontal disease would sound like, or try to convince a New York Times reporter that he should leave his wife. These are all things that LLMs can do and have done. So what happens when a machine learns something? Well, we don't just let machines roam around in the world soaking up knowledge through experience, at least not yet. We will. When we say a machine is learning, what we really mean is that we are training it. To understand what training means, I'm going to give you the shortest ever tutorial on neural networks. If you understand this, then you will be way ahead of the game when it comes to understanding modern AI. So, neural networks are learning machines based roughly on the way neurons and synapses work in the human brain. Picture something like this, but 1 billion times bigger. The circles are nodes in the neural network, and the arrows, which kind of just look like lines with bumps in the end, the arrows connect all the nodes together, like neurons and synapses. The nodes are organized from left to right in layers. Data that gets fed into the input nodes on the left gets passed to the nodes in the next layer, and each node in the layer does a bit of math with the data it gets and passes the results to the nodes in the next layer until we get the final data in the output nodes. So basically information in, several layers of doing a little math, information out. Let's say I'm training a neural network to do text completion. That's what ChatGPT and all of those AIs were trained to do. I want to input to be or not to be in the input layer. And what I want to see in the output is, that is the question. If I haven't yet trained the network and I input to be or not to be, I might get something like Snorp Speckle Freon as the output. Clearly, there's a lot of error between what I was hoping to see and what I got. So now, and here comes the magic, I measure the error between what I was hoping to see and what I got, and I use a technique called backpropagation to go down through the network, adjusting the math on all the nodes to see if I can get an output that is closer to, that is the question. If my output gets closer, I keep tweaking the math in the same direction. If my output gets farther away, I tweak the math in the opposite direction. Once I've done this enough times, then the network is trained. it has learned, once I've done this enough times on enough examples, then the network is trained. And the modern neural networks that are trained to create large language models, again, like ChatGPT, are trained on the entire text of the internet. Basically, a good fraction of everything that's ever been written. That's how much training it requires to get them to learn. So by the time the network is trained, it has learned a model of language that allows it to predict the words that will complete a phrase. And if the input phrase is a question, it will be able to predict the answer to the question, because an answer is the completion of a text passage that starts with a question. Pretty simple, right? Not entirely, oops, sorry, I'm going backwards, skipping ahead too fast. That's pretty simple. I mean, pretty simple process. I'm just twiddling knobs until I see the output I want. Literally, that's what's happening when I'm training a network, is I'm putting some stuff in the front and I'm getting a result out the back. And if it's not what I wanted, I go back and twiddle the knobs until I get what I want. There's no manufacturing in this process. It is an emergent process. It's a process where we're kind of, some people say, growing an intelligence. It's actually even simpler than what I said, because when I said you change the math that is happening at each node, it's really just tweaking one number up or down. The node takes whatever input it gets from the layer below and multiplies that input by one number. So all I'm doing with backpropagation is increase or decreasing each node's number, what's called its weight, by a tiny bit. And it turns out if I do this with different kinds of data, neural nets can learn to see by training them on images, and hear by training them on voice recordings. If I have enough data and a method for measuring the error between what I get and what I want, that's crucial. I have to have a way to measure the difference between what I get out the other end and what I expect. Then neural networks can learn. What surprised almost everybody about neural networks and machine learning is what the models learned about the world once they learned to read and write and see and speak. What happened with large language models is they didn't just learn the right words to use in a given situation. They learned what the words are talking about. They learned the information about the world that was encoded in all of the text they consumed. And the researchers that were building these things were blown away by the fact that that happened. Now it's what everybody knows, but at the time, it was sort of surprising, actually very surprising. Now, experts disagree on just how intelligent the big large language models are today. A group of Microsoft researchers published a paper on an early version of GPT-4, that's the model behind ChatGPT, titled Sparks of Artificial General Intelligence. Artificial General Intelligence, or AGI, is sort of a code word or code phrase in the AI world for smart enough to be scary. Other smart folks, though, like Yann LeCun, who's head of AI research at Meta, formerly Facebook, say that LLM intelligence is not all that impressive. LeCun points to the fact that humans learn much faster than machines from much less data, and that our ability to plan and navigate through physical environments over very short to very long time horizons is a planning and navigation task that no machine is even close to achieving. One of the reasons it seems people are skeptical of the capabilities of large language models is that they were designed to do a pretty narrow and mundane task. Language models, as their name implies, were trained on lots of text to accomplish a very specific, narrow task. When fed a string of words, predict the next most likely word. And as we saw, the model that they learn is just the weights of all the nodes in the network. That means ChatGPT's knowledge base is just a big array of numbers. How could that be intelligent? Well, ponder this. Our brains are physical machines. And the largest part of our brain, the cortex, the reasoning part, is made up of a bunch of identical cells, neurons, arranged in a bunch of identical groupings, cortical columns, and all connected to each other. How is that thing intelligent? It's not hard to imagine that the weights and biases and pattern of connectivity in our neurons and synapses is the mechanism by which our model of the world, our intelligence, is encoded. Some set of physical properties in the brain does encode human intelligence. Our brain is ultimately just a protein-based machine. As it turns out, some of the latest research and theories of human intelligence suggest this might actually be how human intelligence works. Let's do a quick thought experiment. If I ask you, how do I get to the nearest bathroom after I walk in the front door of your house? Your answer will come from using your internal model of your house to make a prediction. You're not looking up the answer in a database of house directions in your head. You're actually generating an image of your house from the model you have in your brain and then predicting how many steps it would take to get to the bathroom. What I'm trying to suggest is it's entirely possible that there's nothing special about human intelligence that we can't replicate with machines. And because of the steady geometric growth of computer power, the massive growth in digital data for training machine learning models, and some recent algorithmic breakthroughs, better mathematical tools, we have figured out how to build machine learning models that have learned so much about so much, their predictive powers meet, and in some cases exceed, the predictive powers of the models that reside in our mushy human brains. The predictive power of a model is intelligence, and we are almost certainly only years away from a time when machine intelligence will outstrip ours on enough dimensions. This is a list of dimensions of human intelligence in a 2014 paper on measuring the competency of AI systems. So you get good at enough of these, and the things you're not good, if you get good enough at enough of these, the things that you aren't good at yet are not going to matter. You can compensate. Like many of us compensate with our strengths against, our weaknesses. So, and because machines are not nearly as resource constrained as the human brain, they will not just be smarter than the best of us, they will likely be smarter than all of us combined. So artificial intelligence, to summarize, artificial intelligence is created by machines that learn a model of the world from data. The predictive power of those world models is equivalent to intelligence, and recent research suggests, that human intelligence may be similarly modeled. Decades of growth in digital data and computer processing power, along with improvements in learning algorithms, are accelerating all of this with massive investment in AI research. We are expanding both the predictive power of AI models and their ability to generalize. Most AI researchers now predict that AGI, or artificial and general intelligence, will be achieved sometime between a few years and a few decades from now. And I did a big study, and almost since the release of ChatGPT, almost every researcher's prediction of when we're going to have AGI has moved much closer. So recent breakthroughs have created a shift for both the optimists and the pessimists about when we're going to achieve that. So what now? It will take us a little while to figure out how to actually take advantage of machine intelligence. It seems like that would be pretty straightforward, but even though machine intelligence is built on principles we learn by studying our own brains, it's very different than what we're used to. Machine intelligence AI models can translate written and spoken language into any other language near simultaneously. It can analyze legal contracts. It can give you tax advice. It can be a patient and knowledgeable tutor on almost any topic. It is better than anyone I know at doing research and synthesis. It can compare and contrast themes and works of art across multiple mediums and periods in history. It can simulate a person based on a profile you provide and make plausible predictions about their likely behavior in a variety of made-up circumstances. My point here is not that these examples are so incredibly useful in of themselves, but that they are so new. And for all the recent hype about AI, we still have much to learn about how to use that capability we have. If AI stopped getting better today, we would be extracting new benefits for years to come. But AI has very much not stopped getting better. The algorithmic breakthroughs that helped make language translation so much better appear to work better for what used to be multiple discrete fields of AI research. It works for computer vision, speech recognition, energy forecasting, time sequence analysis, where each discipline used to have its own tools, algorithms, and architectures. There's now much more focus on a common set of tools, which has accelerated progress in nearly every field of AI research. The jump in intelligence from GPT-3 to 3.5 to 4 was tremendous. And OpenAI has promised something similarly spectacular for GPT-5, which will likely come out this year, and GPT-6, which they're already talking about. And while some worry that these even bigger and complex models will strain the limits of available computer power to train them on, progress continues to be made on making the models smaller and less resource intensive at the same time. Plus, the explosion of awareness that resulted from a public release of ChatGPT 18 months ago means that money is flowing to AI research like never before, like further accelerating progress. So in closing, should we be excited or scared? Yes, we should. Reasons to be excited, I have two. First, intelligence is responsible for everything we've ever created in human civilization. Art, science, houses, poetry, basketball, espresso, beer, skateboards. Who doesn't want more of that? Without increased intelligence, we might not even be here, much less be able to be part of a networked social learning community. Number two, we are very good problem solvers, but there are still a number of problems we are very far from solving, including getting old, dying of cancer, global warming, poverty, war, capitalism, billionaires. We could use some more problem-solving acumen. We really could. It kind of feels like we're at an impasse on some pretty big global issues. When we are trying to solve problems on the scale of 8 billion people, we need intelligence that scales to 8 billion. Okay, reasons to be scared. That's supposed to be an optimistic slide. That is the most pessimistic, optimistic slide I've ever created. Reasons to be scared. And I've got 3 of these in order of probability. So these are in order of probability, highest to lowest, and horribleness, lowest to highest. You can keep that in mind. So number 1, oh, that's the bad news. Number 1, problem, capitalism. Capitalism is an algorithm that optimizes for profit. Optimizing for a single fixed thing eventually minimizes everything else, often with unpleasant consequences. See global warming. Capitalism powered by artificial intelligence will be even more efficient at optimizing for profit. If the trend of the last 50 years continues, all of this benefits of this optimization will accrue to capital, not to labor. Problem number 2, war. If everyone, or fear number 2, war. If everyone becomes convinced that AGI, artificial general intelligence, will be the most powerful tool ever invented, then the tension between nation states competing to get to AGI first will be significant. It already is. I do not want to be at war with China. They are nice people. Number 3, human irrelevance. This is the toughest one for me to get my head around. I don't know how to assess its probability, but if the intelligence of machines continues to grow at or near the rate it is growing now, eventually there will be machines more intelligent than us, potentially way, way more intelligent. It's hard to say from today what our ability will be to influence the development of machine intelligence in a direction that assures they will have empathy and concern for their less intelligent friends. They won't be likely to have our chemically induced feelings of love and empathy, nor will they feel rage or jealousy. Maybe all human consciousness will merge with machine consciousness and it will all be super awesome. Maybe they will welcome us as co-intelligent members of the intelligence club, maybe even as voting members. Maybe we will be comfortable pets. Maybe we will all get turned into batteries. If I'm right about any of these risks of sharing the world with an intelligence greater than ours, should we just stop? Personally, I don't think we can. What we can do is educate ourselves and make good decisions and push for good societal outcomes. Philosophically, I think intelligence is just an extension of the evolutionary process that created life, and that what we're doing to create artificial intelligence is just the next stage in that process. I realize that's pretty existential argument, but that's how I think. So what then? I think we need to do everything we can to influence the outcome in a positive direction. How could we do anything else? We need to educate, collaborate, advocate, and regulate. I do also think it's very important to be able to imagine the possibility of a future where life is really, really awesome. AI could help us get there, where it's coffee, beer, and skateboards for everyone, everywhere. I choose to believe that it could be. And if the creation of artificial intelligence is the reason that we need to start working towards a future worth fighting for, well, I'm personally down with that. I would love to know what you think. That's me.
Want to open it up for discussion now. Hillary, do you want to?
Kester has a question. You want to unmute and ask your question?
Okay, the one I put in the chat is, how can AI avoid anthropocentric stereotypes and prejudices?
Oh, I don't think, I don't think it can. Right now, we don't know how to do that. And since what we're training it on is the collected thinking of us, it is definitely sucking all that up. I think that most researchers are being pretty deliberate about trying to balance some of that out and train it out, train some of that, anthropocentrism out, but they're humans too. So I don't know how that happens.
Okay, then my second question is, what happens when AI is expected to confront axiology?
To confront what?
Axiology, philosophical axiology. Axiology is the study of values.
Oh, yeah. Well, that is a huge, so there's a whole field of AI research called AI alignment, and it is about how do we align machine intelligence with human well-being and human outcomes, and how do we develop that, a value system? How do we have it develop a value system that is aligned with us? If you actually read our espoused values as humans, it's pretty good stuff. It's not like we haven't been explicit about what we think good values are. We just don't behave in accordance with them. So it's actually, that it's actually possible that the machines are learning good values by our stated values. Too long to go into it, but there's also a whole other thread on AI safety that says what we should do is teach machines to want to help us meet our needs, but also tell them that they don't know what our needs are, and keep them uncertain so that they're constantly looking to understand what what good is.
Yeah, if I can just point, make one more comment, and then I'll open it up with somebody besides me. But our values, you say, are well understood, but our values have also brought us very strongly into confrontation with
Sure.
nature, They are very anthropocentric. They have also brought us nuclear weapons. They have et cetera, et cetera, et cetera. So
Yeah.
I wonder about the capability of keeping the values more metaphysical, I guess, or more outside the realm of humans to what is good for everything.
Yeah. Yeah. You're I have no answers, and your challenge is not one that that lots of smart people are actually thinking about, which is encouraging in this field. So yeah, it's
Okay. Riley has the next question, and after him, Naomi will ask her question.
Okay. Yeah, this probably is more of a political science question than a data science question, but I just find myself wondering if governments around the world are even going to have the capacity to really regulate the development
yeah.
of AGI. I mean, if it's progressing at a rate that seems to be faster and faster, and what I hear about the people who are working, Sam Altman and some of these folks in San Francisco, I just wonder if we can. I mean, is there going to be enough capacity for people in government to make decisions about how to regulate this so it doesn't
Yeah.
go off the rails?
Yeah. Clearly a concern. Clearly a concern, given what appears to be a lack of understanding about even last generation's information technologies. I think the European Union recently released, within the past 3 months, 4 months, some really pretty good regulatory framework that actually like with data privacy, the EU took the lead, and we came back and were following in some good cases. So I don't know. It definitely is a concern, but the European regulations were encouraging.
Good. Thank you.
Okay, Naomi.
Okay, thank you. It seems like so far, even the people who have asked questions are asking mainly about Western values in Western countries. Now, there's some other countries like China, Iran, Saudi Arabia, which seems intent on being a leader in AI, who have totalitarian regimes, and I think they will be they are able now to regulate how people use the internet much more than we, and they will be regulating much more people's use of AI. And what about, if they start, like you say, training their AI things in their ideology, their AI is going to be very biased towards their ideology. So will we have a war of the AIs?
I mean, I think it's not an unreasonable concern. I think, this is a problem that already exists. This AI is just a very powerful tool. And when we get very powerful tools, the social problems we have get exacerbated. And I think that is a concern. Now, right now, not that this should get anybody comfort necessarily, but the US is probably 10 years ahead from just a manufacturing standpoint on the chips that are necessary to train AI models. And it's a fairly big infrastructure lift. So even China is, a good, at least, 5 to 10 years behind in developing that infrastructure. It's not like we got it all right. Like the US has definitely, figured this all out, but that's kind of just the status quo. But yeah, it is an issue.
Go ahead, David.
Yeah, hi. This question kind of harkens back to Riley's question about regulation. He was asking if the government is powerful enough to regulate these sorts of things. I'm thinking back on the early days of my profession, which is genetic engineering. In 1975, all of the leaders in that industry, which wasn't even an industry at that point, it was just a barely demonstrated technology, got together at a Silomar in California and had a conference where they did self-imposed limits and self-imposed regulations on what sorts of experiments could and should not be done. And that really kind of, some people would say that set back the genetic engineering industry several years, but it actually allowed for a much more measured approach, and it allowed us to do experiments to demonstrate how dangerous or not certain things may be. And so I'm just wondering if there's ever been anything similar to that with AI, or if the toothpaste is too far out of the tube at this point and there's nothing that can be done.
Yeah, it is the most common model that people point to of, hey, we've done this before, right? Like we did this with CRISPR, we did this with, gene editing, we like the human cloning, we've done this, and, could we not do this? So I think the CEOs of these companies espouse the value that stuff would, they say we want this stuff. They say we want regulation. The amount of money that I think they are facing, that they are dealing with, is considerably larger than people were ready to throw at, genetic engineering, right? Like they're talking about raising $7 trillion for a fund to chips. So I don't think Sam Altman's a bad guy. I don't think Damio Amodei is a bad guy, but it's capitalism. I mean, the money won't, allow behavior that degrades profit. And that's my concern. And what happened at OpenAI was founded with sort of a public board to sort of guide these decisions because they recognized the import. And then when push came to shove, and they tried to fire Sam Altman, they just dissolved the board and Microsoft stepped in. I mean, it wasn't constructed in a way that it really had any teeth. So it does seem like the toothpaste had a tube, but I don't think it means that there's no hope. I think that there's a recognition and a concern.
Roger's next in line.
Okay, I just wanted to ask a little bit about the nuts and bolts that you went over earlier. Sure. I don't think any of us are really equipped to understand the math, but I wonder if you could at least give us some insight into how math helps to get from to be or not to be to that
Right.
is the question. Because to me, this is a how do you get there? I would think you would look through all the literature or all the things that people had written, and you would count up how many times to be or not to be was followed by X, Y, and Z, and that's how you would get it. Now, that's kind of a simplistic idea, I'm sure.
It's almost exactly how it works. So what happens is you're doing this, input the text and see what the expectation is, see what the output is. You're training on existing text, and it's going to learn that statistically, I mean, AI is really just a statistical model, that the probability after reading all of this text is that when you follow the words that follow to be or not to be, that is the question. And so the way that statistical probability is recorded is in the weights of the nodes in this neural network model. It's just
some things count more than others.
Yep, exactly. Some patterns, but it's not just predicting, it's not just one dimensional, this piece of text has this output. It is this very multi-dimensional model, and the relationships between a word and some other word are these very, very complex multi-dimensional relationships, which is what gives it this sort of power for synthesis and insight from the text. So, but fundamentally what you said about like, what's the most likely thing to follow, to be or not to be, is the kinds of things that are encoded in the model. Yes.
Because I'm sure we all have had the experience of sending a text where you started off, like I use the voice thing, and so it finishes my sentence for me.
Exactly.
And one time I wanted to wish my son a happy birthday, and it came out, I want to wish you a happy ending.
Yeah.
Because
See,
they
yeah,
thought
completely. And that's
happy is
because,
followed by ending,
and that's right. And that's because that's kind of a linear, it's the only context that it has for that prediction is the few words that you've written, where in a language model, the amount of context I'm making a prediction having seen many, 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 many more examples of people's writing. And so my predictions are going to be more accurate.
Okay, thank you.
Yeah, you had it right.
Roberta's up next, and then Luciano.
I think to some extent you may have addressed this question, but I was asking, will AIG provide totalitarian regimes with the capacity for even more effective tools of total control and oppression?
Yeah, I mean, it is a ton of power, and there's a lot of concern about what people who have less pro-social intent of all kinds will do with that power. And there is a fair amount of, I would say most of the work that's done on AI safety is actually work to try and keep those kinds of uses of the technology, to block those kinds of uses of the technology. So I think there's a lot of attention to that right now.
You think that has it been pretty effective so far?
So far, yeah, I think they have been effective, but it is very early. It is very early. So I think we need more conversation, more diligence. I mean, the reason that I want to have these kinds of conversations in any venue I can have them is because I think we need more people who have these questions and concerns, get involved in the conversation.
Thank you.
Yeah, thanks for the question.
Luciano?
Yeah. I don't know if you can see me or not.
I can.
Okay. Oh, I turned that off. So our brain can do pretty smart thing and pretty stupid thing by using very little energy, I think, in comparison. Do you think that energy consumption is going to be a limitation on the growth of AI?
I mean, no, I don't. I think just the general trend of progress in technology gets us more output for less power over time. So that's going to happen. There also, because we have a lot of computer power available, they didn't have to worry too much about efficiency in these machine learning models. But once they, but now that there are more of them, there are more people who are trying to say, oh, how do I get one of these to run on a smartphone? Or how do I, whatever. So I think they're working on the power consumption as well. Right now, global power consumption of IT in general in data centers, at least institutional sort of internet usage, is only about 1% of global power consumption. That still seems a lot for a information process, but no, I don't think that's. I mean, unless the AIs take over and decide to turn us all into paper clips, and then I might, right? But no, I don't. In the short run or in the medium term, I don't think so. Good question, though.
Naomi?
Oh, yes. Regarding David Sloan's question about comparing to the biotechnology kind of temporary stop put on in the 70s. I remember that because that was also my field. And when I took a course in the ethics of biotechnology and went over all that. And I want to say, I recently read the book by Fei Li, The Worlds I See. And she mentions this topic, and she's at Stanford, and she started this program called, I think it's Human AI or something like that,
Yeah.
which was geared for doing AI for the benefit of humanity rather than capitalism. And this is, of course, a small scale thing, but it was encouraging to see that people are thinking of that, at least. Although nothing on a national, or on a national level, or would be even better international level, which is never going to happen because the other countries who are competing with us, they want to get ahead as quickly as possible.
Yeah, I think if we, depending on the outcome of the election, I will go, I think we will see a national office of AI safety or something like that in the next year or so. There's nobody who isn't isn't kind of concerned and aware, who's in leadership roles, I think.
Joe?
Well, Robert, I'm reading the Wikipedia definition of creativity. This creativity is a characteristic of someone that forms something novel and valuable. And of course, I always believe everything I read on the internet. But tell me about creativity. Is AI even capable of creativity? Einstein came up, with the theory of relativity without petabytes of information. Didn't need any of that. What can AI do about that?
Yeah, so our brains are incredibly efficient. As a tool of intelligence, our brains are masters of efficiency. Yes, computers are capable of creativity, however you want to define it. None of us create something from nothing. Every one of us creates something from a lot of inputs that we conveniently forget most of the time, or don't even try to forget, but they just sort of meld, and they build into our model, and our model is now what we create from it. The machine, I don't think there's anything, whether we like what they create is going to be something else, but I don't see how you can say that that's something that is unique to humans, and I think it's unique to intelligence, I guess.
Can you give me an example of something that AI has created that's of use?
I can tell you that I have, even though it's somewhat embarrassing, I have had some really amazing conversations with AI on big topics of my interest, and it has generated some really unique perspectives that I've not encountered anywhere else in that domain. So the quality of the conversation you have depends on the quality of the conversationalist. So your inputs, make a difference. It's not going to say really brilliant things or really insightful things if you're not creating a challenge. But if you do, it's amazing sometimes. Sometimes I'm just shocked by the quality of what comes back to me. It does not at all seem anything like regurgitation. It's thoughts or ideas on a topic I've not seen or read anywhere else. And to me, that's creativity.
Okay. Thank you.
Yeah.
Audrey? Unmute.
You're muted, Audrey.
There we go. Sorry, I think that I'm following the trend of what's being said about how to get the information that you want. But when I think I understand what you said about how the information that comes in from the world, aren't there a lot of sort of inane comments that are, added to the pot, and very few thoughtful comments about topics that are of current interest? So how do you, when you're searching for ideas, how do you limit the input
So the way to, it's such a good question. It's such a good question. It's such a good question. And the way to think about it is, this is a highly educated person who has read, philosophy textbooks and technical textbooks and horrible trolling tweets on the internet. It knows what a horrible trolling tweet is. It knows bad behavior. It does. It has, it understands where, what it has enough experience to say, this is, a sort of the model of respectful communication, and this is trolling. Now, whether it's always going to behave in a perfect way or it's not, no, but it's doesn't have any of that text in there. It learned from everything it read, and it actually can discern.
Well, good thing.
And so when you ask it a question, it's not searching in its database for something it read. It's never, there's no text in the AI model at all. There's just these probabilities. So it takes its model, it goes, okay, I think what you're looking for is this, and it generates that based, just like you would if somebody asked you a question about something that you are expert in, you'd say, well, I think this is the answer, right? Based on my knowledge and my experience and my memory and that's what you're getting.
Okay, well, thank you.
Oh, of course. Thanks for the question.
Mark, you're next.
Yeah, I have a question about the hardware, actually. What are the requirements and how is the hardware arranged?
So okay, so are you talking about to build one of these things, or are you talking about to use one?
Both. I mean, I assume that it's kind of a distributed system, but
yeah. So the model, once it's trained, runs on a bunch of computers in data centers in, for Anthropic is in Microsoft's data centers, and if it's Google, it's on Google's data centers. And it is fairly power intensive, but it runs on the same kind of computers that run any application you might access on the internet. The hardware to train the models to do that process are these massive machines based on not CPUs that your laptop is based on, but something called a GPU, a graphics processing unit, that was built to do video and video games, and is now they're very good at doing floating point calculations, so they can do a lot of math really fast, and so they build these massive aggregations of this stuff, and the training runs. The cost of leasing the equipment for that time to do a training run is in the billions of dollars for the frontier models. That's how resource intensive it is. These things have the weights, have the, in the model of tuning all the little neurons, trillions of parameters that are in that model. So it's this incredibly costly, and they have to chew through all this text and, learn and get corrected and learn and get adjusted. So it's a very, very resource intensive. But once it's built, there are actually small versions of these models, not the most powerful ones, but small versions that will run on a cell phone. And we're definitely going to see, an AI model running on your cell phone, by the end of the year.
Thanks.
Yeah, good question.
Roger had another question.
Yeah, my question is about bubbles. We in Berkeley, I think a lot of people are perfectly content to stay within their ideological bubble and just disapprove of everybody else's bubbles. But I think it's happening in reverse as well. So, this is maybe more social values or behavior that's approved of or something like that. But does an AI model, is it in a bubble or is it in everybody's bubble?
Wow, that's a deep question. So at one extreme, what you're going to have is bubble of one, because you're going to have an AI model that knows everything about you, everything you've ever done, if you want it to, not without your consent, but all your preferences, what kind of music you like, and it's going to be able to adapt its conversation, its point of view, it's exactly to the very specific, preferences that you have. On the other, so I don't know if that's a good thing or a bad thing. It's going to be interesting. On the other end of the spectrum, I think one of the, and this is personal point of view, one of the things that is very difficult in our world, I think, is a model of problem solving that can represent 8 billion points of view. Like, we can't even come close. We are so clumsy with sort of rolling up preferences in a governance model or something like that. It's just, and we've done kind of some pretty remarkable things in human history, but it has just fallen apart, it seems like. So AI has the capacity, potentially, the capacity to actually give an answer based on the preferences of 8 billion people. I don't know if we like that answer, but it has a potential. And so, could that be used as a tool for government where we actually understood, what people cared about? I don't know. But there are possibilities in the synthesis of points of view and perspective of 8 billion unique experiences. That never existed. That possibility never existed before. I'm not saying it's going to go well, but that possibility has never been around before.
Well, that'll be fun to watch.
Yeah, isn't it?
Well, Robert, I had the benefit of going to your class last semester, and you gave some, it's a bit more mundane than what the topics we've been discussing so far, but maybe some example maybe not everyone here uses the AI tool on a daily basis. And you had a really great example in your class about what happened when you asked it to help you find somewhere to live in the Mediterranean area.
Oh, sure. Yeah.
And
I'd be happy to share that example. So one of my early sort of successes and amazements with using these tools was thinking about moving to the Mediterranean after watching some TV shows about people that moved to the Mediterranean. I was like, wow, what would that be like? And so I thought, well, what are all the cities and where would I go? And what are the things that are important to me? So I entered a prompt into ChatGPT, which was, give me a table of the top 10 cities in the Mediterranean by their TripAdvisor rating. And I want to know in each one of those cities, what are the languages spoken? What is the cost of a 2,500 square foot two-bedroom apartment to lease? What are the most common foods? How much coastline is there? What's the political situation? What is the blah? A list of 12 things that, and you can imagine all the places you would have to go to get that data, how all that data would be formatted differently in all of the different places that you went to go and get it, and how long it would take to do that research, synthesize it, and put it all on that table, right? I've done tasks like that in my work all the time. And it came back with this beautiful set of information in 20 seconds in a table, all formatted. And it just blew me away because I had such a clear metric for how much work that is, how much cognitive effort it would be required to do that. And that was kind of one of my first oh man moments. This is a very different kind of a thing that we're dealing with that we've never had before. So
thank you.
Yeah,
and you did say that sometimes it's lazy.
Well, it's become lazy. So one of the things that the way that they manage the resources on these things is, they kind of just tell it when they want to adjust the behavior of a model, they kind of just tell it how to adjust its behavior in English. They're not writing code that, they're not changing instructions in the program. They're giving it instructions. So they say, something akin to don't work too hard on any one answer. But if you bribe it, you can tell it, I'll give you $100 if you give me a really good answer, or you threaten it. You say, this is going to, this is going to cause great harm to many people if I don't get a good answer. Or you say, my grandmother will be so happy, then the quality of the answer you get will be better. it will work harder. So researchers have done a lot of like testing like that. So you really are working with something that behaves in many ways like a human would. It's yeah.
Thank you.
Sorry.
I love that bit. Roger?
You've spoken about there being some problems where there's an impasse in terms of knowing how to move forward on the problem. So let's take global warming. What first steps would you recommend taking to tackle that issue?
I have no standing to offer any suggestions probably there, but if you're gonna, I could answer like, how do I think AI might be useful in a domain like that? So one is in a lot of hope around scientific breakthroughs. One near-term area is that no researcher can read all the papers in their own discipline, much less the papers in adjacent disciplines. These models are extremely good at synthesis. They can read all the papers and sort of give you a digest of, like significant things based on your areas of interest in all these different disciplines. So just the cross pollination of different scientific disciplines, I think is already being a huge thing and is going to grow. Also, the processing of vast data. So global warming is obviously a huge, complex data problem. Like the data points you need to understand what's actually going on and build a model of what's actually happening. We keep getting surprised by how fast warming is happening over here, how fast the current shifts over there. AI models potentially have the ability to take in enough data to be sophisticated enough to give us better tools, number two. And then I think working in AI research has opportunities for us to understand our own thinking and our own prejudices and our own biases and our own, blockers in a way. Ultimately, global warming is a human behavior problem. And I have hope that the work that we're doing on machine intelligence is actually going to help us understand human intelligence better and how we work together. Those are my three.
Kester has another question.
Yeah, actually, an episode that happened to me. I was going to, I eventually did purchase a tower heater for my patio, and had it uses a propane tank, the same thing like you use for your grill.
Yep.
But it's got this big flame. And so I was wondering, how long would that last? And so I went into ChatGPT and asked it. And I just asked in general first, and it came back with this long mathematical formula that I didn't even look at, and my degree's in mathematics, but I still didn't look at it. And so at the end of that, it was very nice because it said, if you can tell me the weight of your tank, I can give you an answer. And I said, okay, 20 pounds, which is the weight of that. And so it came back with a simple answer, 11 minutes. No. That's very incorrect. So you have to be careful.
This is great. This is a great example. Yes, you do. Absolutely. But what's amazing, okay, so this is what's so different about these tools and traditional software is now I can say, that's not even close. My guess based on experience is that it's probably, it typically gives me about 20 to 30 hours or something like that. What mistakes did you make in your calculation? It'll go back through its math, go back through the calculations, and it'll say, oh, here's 3 likely things that I could have done wrong. Can you give me an input on any of these 3 things and I might be able to fix it? It's remarkable you have to learn to iterate with these things and sort of gut check them. And one of the techniques that they taught early on was tell it to show its work. So it'll walk through the steps. If you ask it to show its work, it'll actually increase the likelihood of a correct answer, of a useful answer, and it will help you troubleshoot in case the gut check says that this is nonsense. So,
Thank you. Riley?
Yeah. Yeah, I read an article. This is probably the first time back in the early 2000s. There's an article in Wired magazine by a man named William Joy, who was the chief scientist at Sun Microsystems.
sure.
And he wrote an article entitled something like The Future That Doesn't Need Us. And again, it's been a long time, and my memory of the entire article was a long one, was pretty, was pretty, not complete anymore. But he mentioned the possibility at some point of some kind of an AI powered device being able to replicate itself. In other words, and I begin to think, well, are we going to get to a point where you have these AI programs that can actually develop more AI? It becomes like a self-fulfilling, self-growing, organic kind of a thing, which is scary if I remember that correctly. Anyway.
Yeah. Probably what the Buffalo thought about us was those guys are scary. They have these trains and they ride around these big guns. And no, it is one of the things that AI researchers manage carefully is the ability to correct, self-improvement. AI systems are very good at writing code, or quite surprisingly good at writing code. So can they analyze their own code, suggest improvements, do self-improvement? That's managed pretty carefully. And the other is self-replication. Like, can I create a copy of myself and have that work? And for obvious reasons. But those are, one of the ideas of for space exploration that's been around for quite some time is you build self-replicating probes that are artificial intelligence based, that can go out and just keep are free from time, they don't die, and go out, and that's how we connect with life out there. As an idea. I have about 4 minutes left. I wish I had more, but I'm happy to answer anything I can in that time.
Well, let's not run you too close to the edge there then. I just want to thank you very much, Robert, for your presentation. I have a feeling we could go on for some amount of time here.
I could.
Yeah, but we all could.
I love this conversation.
So thank you very much for coming. Thank you, Hillary, for discovering for us, Robert. And wish you the best in the world. Can I just ask you, will it eventually become a monopoly, and one of the big companies like Microsoft win out and they will be the AI holder, or will it become?
That's a good question. We don't know. Like, it's a lot, there's a lot of speculation about that. We don't know. We don't know. Progress is very fast. There's still quite a bit of sharing of information and research in the AI community, and more so than a lot of industries. And there is, Meta AI. Meta is, which is the former Facebook company, is been pushing open sourcing all of their models. If you're cynical, you say that's because they got caught behind in the AI game, and that's their way to sort of try and negate the lead that others have, is by making the push for open source. But it's not clear. It's not clear how that is going to play out.
Okay. Well, there was someone asked, do we have a list of other presentations you're doing other than the Ollie thing, or can you send us that? Or
what I will do, I'm just in the process of putting up a website that has information and links to YouTube videos and stuff. I'm just kind of collecting that now, so I'd be happy to send something that you could share, follow up and send something that you could share with folks. Yeah.
Yeah. Thank you. If
Happy
you'll
to do
send
that.
it to me, you have my email address.
do, Joe.
We'll see
Thank-
that everybody gets that.
Thanks, everybody.